All right, so now what we're going to do is we're going to look at the idea of a test for significance. What exactly is a test for significance? And what's the logic behind it? Well, I'll give you a non-numerical example. This is the example I usually use in class. I want to know what kind of animal there is. Let's say I'm at the zoo. I'm at the zoo, and I'm here at this. There's a caged animal. A little cave in here. Right, and this is the cage. So there's an animal in a cage, and that animal is shy, so it's hiding in its cage, or in the little cave inside of its cage. So I can't see the animal, which is kind of frustrating. You go to the zoo to see animals, and they're shy, but we don't want to be cruel. We don't want to force them to perform. We'll let them come out when they want to. That's fine. But I don't know what kind of animal's in there. And there's a little place where there was a placard, and the placard was broken off. A little sign saying, "We'll fix this when we're working on it. Under construction or whatever. Under repair." So I don't even know, the sign won't tell me what kind of animal it is. So I have to decide, what kind of animal do I think it might be? So what I'm going to do is I'm going to hypothesize. My hypothesis is, I'm going to make two hypotheses. The first one is the null hypothesis, or H naught, H sub 0. And for those of you who are from the British Commonwealth, you probably know that naught is just another word for 0 in British English. Americans probably don't know that, but yeah, naught, N-A-U-G-H-T, is just another word for 0 in British English. So, H naught is always a statement of equality, or something what something is, as opposed to what something isn't. So, let's say what this is the animal is feline. Feline means cat-like. So, like a lion, a tiger, a puma, a bobcat, some kind of cat-like animal, a feline animal. So let's say the animal is feline. My alternate hypothesis, HA, is going to be the animal is not feline. My alternate hypothesis. The animal is not feline. All right. Now what I need to do is I need to gather some data. So after I've hypothesized, I gather data. I run an experiment or something like that, or do a poll or something like that. I gather some information. Now in this case, what I'm going to do is I'm going to gather information by looking around the cage. And my question is, what do I see? Do I see fur? Because as you know, anyone who has cats knows that cats shed fur. All cats shed fur. They will sometimes scratch themselves, or they will lick themselves, and then cough up hairballs, or Anyway, whenever you have some sort of a feline, they're gonna shed some fur. So do I see shed fur? So let's take both cases. Let's say there's two possibilities, and I'll do each one separately so we get the idea. Let's say we see fur. Oh good, I see fur. What does that mean? That means that the animal very well could be a feline. It doesn't mean necessarily the animal is a feline, but if it were a feline, if my null hypothesis were true, this is consistent with what I would see. So I say, if H naught were true, this result would be common. It would happen all the time. If this really were a feline, this kind of result is something I would see commonly. It's not unusual at all to see this. So in which case I would say that it is consistent with it being a feline. It doesn't mean that it is a feline. I can't conclude that my null hypothesis is true. All I can do is say, well, the data doesn't suggest differently. I mean, it could be something else that sheds fur, like a meerkat's not really a cat, but it could be like a bear, or it could be a coyote, or it could be, a badger, some other animal that has fur, but it's consistent with it being feline. On the other hand, what if I look around and I see feathers instead of fur? Is it possible it could still be a feline in there? Well, yeah. I mean, it's possible that maybe they just barely cleaned the cage, so there's no fur around, and a bird flew in and it caught the bird and ate it and left some feathers around, right? That's the only thing I can think of that might possibly, if the null hypothesis were true, could this happen? So it could, but boy, that's really an unlikely circumstance. So I'll say if H naught were true, this would be super unlikely, or really rare, right? In which case I can conclude that I think this is evidence that my null hypothesis is wrong, that the animal is not feline. It's that my alternate hypothesis is actually correct. That I think this is evidence against my null hypothesis, because the results I have are really rare. In general, what we'll do is we'll come up with what's called a p-value, which is, if my null hypothesis were true, how likely are my results? Are they common or are they rare? And if they're rare, I think I have a good, so if I'll get what's called a p-value. And if my p-value is really low, these kind of results are really rare, then I will say I have evidence against my null hypothesis. On the other hand, if my p-value is fairly high, it's a very common kind of result. It happens much of the time, say 20% or 50% or 75% of the time, I'm going to see this. That's pretty common, and I'll say, I really don't have evidence against my null hypothesis. It's definitely in the realm of possibility. Now remember, it doesn't prove that it's true, because I'm assuming that if the null hypothesis were true, just like if it were true, you would see fur. That doesn't mean that it has to be a cat. It just means that if it were a cat, this is what I would expect. So my evidence doesn't discount my null hypothesis. On the other hand, if I see feathers, the likelihood of seeing this is really, really rare. This should hardly ever happen. You see feathers and no fur in a cage that has cats. So it could, but it's really, really unlikely. So in this case, my p-value is very, very small. It's some very unusual event. It only happens maybe 1% of the time, or maybe even less. In that case, I think I've got pretty good evidence that the animal is not feline, that this cage probably holds some other kind of animal. Maybe it's some kind of bird, I don't know. But you get the idea. So this is the general idea of a test for significance. Now the question then becomes, well, what is rare enough to be considered good evidence against the null hypothesis? And that usually is something you have to decide before you run the test. I didn't decide it here. This is just a kind of a thought experiment. But in general, with a small sample size, we use 0.05 or 5%. If something only happens 1/20th of the time, it's probably rare enough that we think it's suspicious. I think that the null hypothesis might not be true. With a larger test, that might not be sufficient. What we call this is the Greek letter alpha. It looks kind of like a fish. Alpha is 5%, means that that's the cutoff we have for what is rare enough to represent significant evidence against the null hypothesis. So the test for significance says, is it significant? Do we have significant evidence against the null hypothesis? And the answer is yes, if the likelihood of my results is less than alpha. So if my p-value is less than alpha, something is really rare, it doesn't happen often, 5% of the time or less, then I'll say I have significant evidence against my null hypothesis. I think the alternate hypothesis is true. On the other hand, if my p-value is greater than alpha, I will say there's just not enough evidence to discount my null hypothesis. It's consistent enough with my null hypothesis that I can't discount that as a possibility. And that is the logic behind a test for significance.